All right, it looks like we're going to be doing some, looks like a normal distribution. So that's usually going to be z-scores, and I should probably mark this down. Like this is the formula that we tend to use, and it's always going to be, that sort of normal curve. Okay, so we got a sample of 1,000 cans. How many should have a volume of greater than 350 milliliters? Okay, so the average is at 355 according to this, and then our standard deviation is going to go, okay, so standard deviation is 2.5, and I'm going to reuse that a bunch, but I need a volume greater than 350. So 350 is going to be here, and I need that, plus I need the 50% of it. Okay, so I need to figure out the z-score for this 350. So let's see, z is going to be equal to 350 minus 355 over 2.5. 5 over 2.5, which is the same thing as negative 2.0. Okay, so that's a nice z-score. So if that's my z-score, then I need to go to the table. Okay, so that gives me my z-score. Now what I need to do is I need to take this 50, there's going to be a 50% from here, and we're going to add on those two areas, and I get 0.9772. Okay, so that gives me a percentage. So like 97%. So I need to do that 0.9772 times 1,000. So I would expect 977.2. I guess I need whole numbers, right? So there's my solution. Okay, how many of that group of 1,000 would have a volume between 352.5 milliliters and 360? Okay, so again, do a quick little sketch with 355. So I need between 352. Okay, so I should take that. So that looks like a z-score of like a -1. That's my guess. So I think I've got a z equals -1 because it's subtracting 2.5. And this one looks like it's up 2. So I am cheating just a little bit here by recognizing some quick values. Okay, so at -1, I get 0.3413, and up to 2 is again 0.4772. So it looks like I just need to add those together. 0.8185. Now I need to take that and multiply it by 1,000 because I'm taking a sample of 1,000. Okay, so 81.85% of 1,000. And that's going to give me my answer, which is, that's how many cans. Oh, I need a whole number of cans, don't I? So 819. So I need to find the z-score of a can. Okay, so just going to record again. All right, I'm just going to record again that mu was 355 and the standard deviation was 2.5. Okay, so the z-score for can, so that's, remember, z is equal to x minus mu over sig, okay? And so that is 351 minus 355 over 2.5. So that's 4 over 2.5. And I get that as being, that should be a -4 on top, shouldn't it? I get that as being a -1.6 when I put it into a calculator. All right. What volume would correspond to a z-score of 2.2? Well, if I use that same formula, I could go 2.2 is equal to, let's see, so x minus 355 over 2.5. Now I could just do some rearranging here. So let's see, it'll be 2.2 times 2.5 because I'm multiplying both sides, and then I would add 355 to that. And let's see, that gets me 360. I get 360.5. You might want to double check my calculation. All right, we got one more to do here. So that's 355 just so I can remember these again. Okay, so how much would a can have to hold to be in the top 5% of the recorded volume? So that I need let's draw this out real quick. I need it to be up here, so that's 95% that way and 5% that way. Okay, so this right here, okay, that's 50%, right? So I need this to be at 0.4500. So I need to look at the table and find the closest thing to that value. So what I find is it looks like it's at about, so if the area equals 4.4500, the closest that I'm getting is like a 0.4504, which converts to a z-score of 1.65. It's sort of right between 1.64 and 1.65. I'd go with either one of them, and it'll be fine. So how much would it have to hold? I need a z-score there. So 1.65 equals, let's see, x minus 355 over 2.5. Or 2.5 times 1.65 plus 355, and throwing that into a calculator, I get that as 359.125. Okay, so let's go with 359